Hey guys, it's Ms. Johnson and I'm here to bring you the second part of section 4.3. Today we're talking about the scope of inference. So we just have kind of a wrap-up discussion today. It won't take us too long to get through. If you're picking up with me in your textbook, I'm on page 303 and I'm just going to go through kind of the last couple pages of this section. So I want you to take a look at the table that's at the top of page 304. It's this table right here. This is a table that you are going to refer back to quite a bit for the rest of the year. As we start running tests and doing tests on our experiments and trying to make assumptions of our data and things like that and trying to make inference about a population, we're going to look back at this table throughout the whole time. So it says the scope of inference. Random selection of individuals allows inference about a population from which the individuals were chosen. So we know that we're pulling data from a sample. It's nearly impossible to get data from an entire population. So we have to pick a sample. We choose our sample wisely, which is what we talked about at the beginning of this chapter. Then we run an experiment. We do random assignment. Random assignment is really important. Random selection is really important. So random assignment of individuals to groups allows inference for cause and effect. So this is kind of a table that you're going to reference quite a bit. It's a little matrix here. The columns were the individuals randomly assigned to groups. So was random assignment used? If random assignment was used, then you can make an inference about cause and effect. Okay? In the rows on the left-hand side, you see where individuals randomly selected. Okay? As long as individuals were randomly selected, then you can make an inference about the population. So this is kind of your sweet spot. This is what you want. You want random selection and random assignment. Okay? If your individuals were not randomly selected, then that puts you down in this bottom row, which means you cannot make inference about the population. If your individuals were not randomly assigned, then that puts you over here in this right column, which means you cannot make inference about cause and effect. Okay, so we have to look for those two things, random assignment and random selection. Actually, I probably should have said that in the other order. First, you have random selection when you pull your sample. Then you have random assignment when you assign them to groups. As long as those two things happen, then you're in this sweet spot. Okay, and this is the sweet spot where we're going to be testing our data results, our experiment results in future chapters to see if we can actually say, yes, this one treatment caused this effect. Okay. So there's a lot of challenges. There's a lot of things that have to go right. A lot of stars have to align in order to imply or infer causation. There's several criteria for establishing causation when we can't do an experiment. So if we're not doing an experiment, it's even harder because that's just an observational study and we lose a whole lot of control. So if we're trying to establish causation for an observational study, we need to have a really strong association. We need to have a really consistent association across the whole data set. We also need to have larger values of the explanatory variable that are associated with stronger responses. We're looking for like those unique outliers that are associated with stronger responses. It says the alleged cause has to precede the effect in time, and the alleged cause has to be plausible. So it's really, 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 really hard to establish causation when we're looking at an observational study if we're not doing an experiment. Most often, you're going to be testing these things when you're actually doing an experiment, which makes it a little bit easier because you've got that control group and the treatments and all that. So this is an important topic. It's not necessarily something that's tested on the AP exam, but this is just an important topic in the world of statistics in general. So this is for sure something that you would encounter if you were in a statistics class beyond high school that was going towards your major, because all of this statistical analysis is really put into play in a lot of different fields, in the business field, in the medical field, in a lot of different areas. Statistical analysis comes up. So it says for basic data ethics, all planned studies must be reviewed in advance by an institutional review board. charged with protecting the safety and well-being of the subjects. So it's really important that your study is like an official study that's been approved by some board. Then all individuals who are subjects in the study must give their informed consent before data is collected. So the people have to sign up for the study. They have to willingly participate, basically, without you just taking their data. And then all individual data must be kept confidential. That's a really important thing too. Only statistical summaries for groups of subjects may be made public. So you can publicize the results in a summary standpoint, but you can't publicize individual data points. A lot of times these studies are measuring things about your actual person, your actual body. They're a lot of times they're related to something medical or some sort of reaction that's happening in your body. And that gets down to like that medical oath that all doctors and medical practitioners take about, that's data privacy, that's informed consent. They have to be able to protect you in that area. So while these aren't things that the AP exam is necessarily going to test you on, these are just important things to mention, because it's a really good practice if you're going to run an experiment. All right, so that's kind of the wrap up of section 4.3. This is a kind of a tricky section because it leads us into the chapters that follow, but it's not super applicable yet because we're not running these tests and stuff yet. So we're going to do a lot more with simulation. We're going to do a lot more with testing as we get into future chapters of the book. But just kind of understanding the basis of how you randomly select, how you randomly assign, and kind of what some of those basic principles are, so that you can get to a point where you're making inferences about a population. Thanks for tuning in, and I will catch you next time.